Hello there, and welcome to Whispers of Science, where we take the gentle path through the most profound mysteries of our universe. Tonight, we're going to explore something that might completely change how you think about the world around you. What if everything you thought you knew about gravity, the force that keeps your feet on the ground, that makes apples fall from trees, that holds planets in their orbits, was wrong? Not just a little wrong, but fundamentally backwards. What if gravity isn't a force at all, but rather the most beautiful illusion in the cosmos, an illusion so convincing that it fooled humanity for centuries and continues to shape every moment of your existence right now as you listen to this? Your body is experiencing what feels like a downward pull toward the earth. But what if I told you that this sensation, this feeling of weight, this certainty that something is pulling you down, is actually your mind interpreting something entirely different? Before we dive into this mind bending journey, I'd love to know where in the world you're listening from and what time it is in your corner of the night. It's fascinating to think that no matter where you are, gravity, or what we call gravity, is affecting you in exactly the same way. Or is it, if you find this exploration intriguing, or if it helps you drift peacefully towards sleep, I'd be ever so grateful if you gave this video a gentle thumbs up and perhaps subscribed to join our quiet community of curious minds. Now, I do hope this isn't so captivating that it keeps you awake, but if it does well, at least you'll be pondering one of the most elegant ideas in all of physics as you lie there. So settle in, slow your breathing, and prepare to question everything you thought you knew about the force that governs our daily lives, because what we're about to discover might just turn your understanding of reality upside down, or should I say, right side up. For most of human history, we've lived with gravity as a simple fact of life. Things fall down, not up. Water flows downhill, not uphill. If you drop your keys, they clatter to the floor, not float toward the ceiling. It's so obvious, so fundamental, that questioning it seems almost absurd. And yet, the story of gravity is really a story about how our most basic assumptions about the world can be completely wrong. Imagine you're in a windowless room, a perfectly sealed box with no way to see outside. Now imagine this box is sitting motionless on the surface of the earth. You feel your normal weight. Your feet press against the floor. Everything feels exactly as you'd expect. But here's where it gets interesting. What if, without your knowledge, someone carefully lifts this box and places it in a rocket ship, then accelerates that rocket upward at exactly the same rate that objects fall on Earth? Inside your sealed room, you'd feel exactly the same. The floor would press against your feet with the same force. You'd feel the same weight if you dropped something. It would fall to the floor at exactly the same speed. You'd have absolutely no way to tell whether you were sitting peacefully on Earth or accelerating through empty space. This thought experiment reveals something profound about the nature of what we call gravity. This scenario isn't just philosophical speculation, it's the foundation of one of the most revolutionary ideas in modern physics: the idea that gravity and acceleration are fundamentally indistinguishable, that what we experience as gravitational force is actually something else entirely, something far more subtle and beautiful. To understand this, we need to step back and look at how our understanding of gravity evolved, because the story of gravity is really three stories woven together, each building on the last each revealing new layers of mystery. The first story begins with falling objects and a brilliant mind trying to make sense of why things move the way they do. For centuries, people assumed that heavy objects fell faster than light ones. It seemed logical, after all. A stone falls faster than a feather. But then came careful observation and the realization that in the absence of air resistance, all objects fall at exactly the same rate. This was the first hint that gravity might be more universal, more fundamental than anyone had imagined. It wasn't that different objects experienced different amounts of gravitational force proportional to their weight. Instead, every object experienced the same gravitational acceleration, regardless of what it was made of or how massive it was. This universality was the first clue that gravity might be something special. Then came the mathematical description, the elegant equations that could predict exactly how objects would move under gravitational influence. Suddenly, the motion of planets, the arc of a cannonball, the swing of a pendulum could all be calculated with stunning precision. Gravity became not just a force, but a predictable, calculable aspect of reality. But even as the mathematics grew more sophisticated, even as predictions became more accurate, there was always an underlying mystery. Why did gravity work the way it did? Why was it universal? Why did it affect all objects equally? And most puzzling of all, how did it work across empty space? How could the sun reach across millions of miles of nothingness and influence the motion of planets? These questions lingered for centuries, like a persistent whisper suggesting that something deeper was at work, that perhaps our understanding, while practically useful, was missing something fundamental about the nature of reality itself. The breakthrough came from thinking about motion in a completely different way. Instead of asking why objects fall, the question became, what if falling objects aren't actually falling at all? What if they're moving in perfectly straight lines through a reality that itself is curved? Picture this. You're standing on the surface of a giant sphere, so large that it appears flat from your perspective. Now imagine drawing a straight line across this sphere from your perspective. The line looks straight, but to someone viewing the sphere from far away, the line clearly curves, following the surface of the sphere. This is the key insight. What looks like curved motion from one perspective can be perfectly straight motion from another, and what we interpret as the force of gravity might actually be objects moving in the straightest possible lines through a reality that is itself curved, but curved by what curved by the presence of matter and energy. The more massive an object, the more it curves the fabric of space and time around it. And objects moving through this curved space, time naturally follow the curves like marbles rolling along the contours of a bent surface. This means that when you feel yourself being pulled toward the earth, you're not actually being pulled at all. Instead, you're trying to move in a straight line through space-time. But the Earth's mass has curved space-time so significantly that your straight line motion appears curved from your everyday perspective. Think about it this way. Imagine you're walking in a perfectly straight line across a field, but unbeknownst to you, the entire field is slowly tilting as you walk. Your straight path would carry you downhill, even though you never changed direction, even though no force pushed or pulled you. The geometry of the space you're moving through determined your path. This is what's happening with gravity, except instead of a tilting field, it's the curvature of space-time itself, and instead of walking, you're moving through the four-dimensional fabric of reality, following the straightest possible path through curved space-time. The implications of this are staggering. It means that gravity isn't a force in the traditional sense, it's geometry, it's the shape of reality itself, and what we experience as gravitational attraction is actually the consequence of moving through curved space-time. When you're standing on the Earth's surface, you're not being pulled down. Instead, you're trying to follow your natural straight line path through space time, but the Earth's surface prevents you from doing so. The sensation of weight that you feel is actually the Earth's surface pushing up against you as you try to follow your geodesic, your natural path through curved space time. This is why the person in our windowless room can't tell the difference between sitting on Earth and accelerating through space. In both cases, they're being prevented from following their natural straight line motion through space time. By the floor of their room, the experience is identical because the underlying physics is identical. But here's where it gets even more beautiful. This curvature of space-time isn't just a metaphor, it's a measurable physical reality. Light itself follows these curves. When light passes near massive objects, it bends following the curvature of space-time. This bending of light has been observed and measured, confirming that space-time really is curved by the presence of matter. Time itself is affected too. Clocks run slower in stronger gravitational fields, not because some force is acting on them, but because time itself flows differently in curved space. Time, the deeper you are in a gravitational well, the more curved space-time becomes, and the more slowly time passes, relative to regions of flatter space-time. This means that gravity isn't just about spatial curvature, it's about the curvature of time as well, and the interplay between curved space and curved time creates what we experience as gravitational effects. So when we ask whether gravity is a force or an illusion, the answer is subtle and profound. Gravity as a pulling force is indeed an illusion, but it's an illusion that emerges from something far more fundamental, the curvature of space-time itself. We experience this curvature as a force because our intuitions about motion and space are based on our everyday experience of flat, three-dimensional space. But reality is far stranger and far more beautiful than our intuitions suggest. We live in a four-dimensional space-time that can bend and curve, and the paths we follow through this curved space-time create what we experience as gravitational attraction. This understanding doesn't diminish gravity in any way. If anything, it makes it more magnificent. Instead of being just another force, like pushing or pulling, gravity becomes a fundamental feature of reality itself. It's not something that happens in space and time. It's something that space and time do. The elegance of this idea is breathtaking. Instead of mysterious action, at a distance we have local geometry instead of inexplicable forces. We have the natural motion of objects through curved space-time instead of gravity. Being something separate from the fabric of reality, gravity becomes the fabric of reality. And yet, despite this profound shift in understanding, the mystery of gravity isn't solved, it's simply moved to a deeper level. Now we must ask, what determines how matter curves space-time? Why does mass energy create curvature in the first place? And what is the fundamental nature of space-time itself that allows it to be curved? These questions lead us into even deeper mysteries about the quantum nature of space-time, about the possibility that space and time themselves might emerge from something even more fundamental, about whether the smooth curvature we observe at large scales gives way to something grainier, more discrete at the smallest possible scales. But for now, as you lie there, contemplating this extraordinary idea that gravity might be an illusion created by curved space-time, take a moment to appreciate the profound shift in perspective we've just explored. You're not being pulled toward the Earth. Instead, you're following the straightest possible path through a curved four-dimensional reality. The sensation of lying in your bed, the feeling of your body pressing against the mattress, isn't the result of a downward force. Instead, it's the consequence of your natural motion through space-time being interrupted by the surface you're resting on. You're trying to follow a geodesic through curved space-time, and your bed is preventing you from doing so. This realization transforms everything about how we understand our place in the cosmos. We're not victims of some mysterious pulling force. Instead, we're travelers, following natural paths through the curved geometry of space-time itself, and the universe around us isn't held together by invisible forces reaching across empty space. Instead, it's a beautifully choreographed dance of objects following the curves and contours of space-time itself. So what does this mean for your everyday experience? Right now, as you listen to these words, your body is interpreting the Earth's curved space-time as a gentle downward pull. But in reality, you're simply following the most natural path possible through the geometry of existence itself. Every breath you take, every beat of your heart, every subtle shift of your body is occurring within this curved, four-dimensional landscape that we call space-time. But let's pause for a moment and consider just how extraordinary this revelation truly is. For centuries, we thought we understood falling objects. We built bridges, calculated orbits, sent rockets to the moon, all based on the idea that gravity was a force pulling things together, and it worked beautifully. The mathematics were elegant, the predictions were accurate. But underneath it all, we were describing the effects of something far more profound without realizing what we were actually observing. It's rather like looking at shadows on a cave wall and developing elaborate theories about the nature of shadows without ever turning around to see the fire that creates them. Our equations for gravitational force were describing the shadows cast by curved space-time onto our three-dimensional understanding of the world. This brings us to one of the most beautiful aspects of this geometric view of gravity. It explains not just why things fall, but why they fall the way they do. Remember that puzzling universality, the fact that all objects, regardless of their composition, fall at exactly the same rate in a vacuum. This seems mysterious if gravity is a force. Why should the force affect all materials identically? But if gravity is geometry, then this universality makes perfect sense. All objects follow the same curves through spacetime, because spacetime curvature doesn't discriminate between different types of matter. A feather and a hammer dropped on the moon fall at identical rates, not because they experience identical forces, but because they follow identical paths through the curved space-time created by the moon's mass. This geometric understanding also resolves the ancient puzzle of action. At a distance, how can the sun influence the Earth across millions of miles of empty space? The answer is that it doesn't. The sun curves space-time locally, right where it is, and the Earth simply follows the curves in space-time, right where it is no mysterious reaching across emptiness is required. The curvature propagates through space-time at the speed of light, creating a continuous geometric landscape that guides the motions of everything within it. Imagine space-time as a vast flexible membrane and massive objects as heavy balls placed on this membrane. Each ball creates a depression in the membrane, and other objects naturally roll along the curves created by these depressions. They're not being pulled by the heavy balls, they're simply following the shape of the membrane itself. But this analogy, while helpful, is actually quite limited because it still imagines gravity working in a three-dimensional space with an additional dimension for the curvature. In reality, space-time itself is four-dimensional, and the curvature happens within those four dimensions, not in some external fifth dimension. This is far harder to visualize, but it's crucial to understanding the true nature of gravitational geometry. The curvature of spacetime also explains something else that puzzled scientists for centuries: why moving objects in gravitational fields follow such predictable paths. Planets orbit in ellipses, not because some force is constantly pulling them toward the sun, but because elliptical motion is the natural consequence of following geodesics through the curved space-time created by the sun's mass. It's rather like a marble rolling around the inside of a curved bowl. The marble isn't being pulled by the bowl instead. It's following the natural contours of the curved surface. The same principle applies to planets, but instead of rolling on a two-dimensional curved surface, they're following four-dimensional geodesics through curved space-time. This geometric view of gravity has profound implications for our understanding of the cosmos. It suggests that the large-scale structure of the universe, the way galaxies cluster and move apart, the expansion of space itself, might all be consequences of the geometry of spacetime on the grandest possible scales. But perhaps most remarkably, this understanding suggests that space and time are not the fixed, unchanging backdrop against which physics happens. Instead, they are dynamic, flexible aspects of reality that can be shaped and molded by the matter and energy within them. Space-time becomes an active participant in the cosmic dance, not merely the stage upon which it unfolds. This realization opens up extraordinary possibilities. If space-time can be curved by mass and energy, then perhaps it can be manipulated in other ways. Perhaps the science fiction dreams of warping space for faster than light travel aren't completely impossible, perhaps. Understanding the true geometric nature of gravity could lead to technologies we can barely imagine. But even more profound than the technological possibilities is the philosophical shift this understanding represents. We've moved from a universe where objects are pushed and pulled by mysterious forces to a universe where everything follows natural paths through a curved geometric landscape. We've replaced action at a distance with local geometry, mysterious forces with elegant mathematics. Yet this shift from force to geometry raises new questions that are perhaps even more mysterious than the ones it answers. What is space-time made of? How can something curve if it isn't made of anything physical? Why does mass and energy curve space-time in the first place? And what determines the specific mathematical relationship between matter and curvature? These questions push us toward even deeper mysteries about the fundamental nature of reality itself. Some physicists suspect that space-time might not be fundamental at all, but might emerge from something even more basic. Perhaps space and time as we know them are like temperature or pressure properties that emerge when you have many microscopic components interacting in complex ways. If this is true, then the curvature of space-time might be like the waves on the surface of an ocean, beautiful and important for understanding the large-scale behavior, but ultimately arising from deeper, more fundamental processes happening at scales we can't directly observe. This possibility suggests that our geometric understanding of gravity, while far more elegant than thinking of it as a force, might still be describing shadows on the cave wall. There might be an even deeper level of reality from which both space-time and its curvature emerge. Some theories suggest that at the smallest possible scales, space-time itself might be quantized, made up of discrete, indivisible units, like pixels on a cosmic screen. If this is true, then the smooth curvature we observe at large scales might give way to something grainier, more digital at the tiniest scales. Others propose that space-time might emerge from quantum entanglement, the mysterious connection that can exist between particles, regardless of the distance separating them. In this view, the geometry of space-time would be a consequence of the pattern of quantum correlations between microscopic degrees of freedom. These ideas push us to the very edge of current understanding, into realms where mathematics becomes poetry and our everyday intuitions about reality completely break down. Yet they all build on the fundamental insight that gravity is not a force, but a manifestation of geometry. As you contemplate these ideas, feel how your body rests against your bed or chair. You're experiencing the illusion of gravitational force. But now you know the deeper truth. You're following a geodesic through curved space-time, and the surface supporting you is preventing you from continuing along your natural path. This isn't just abstract physics, it's the reality of your existence right now. Every cell in your body, every atom that makes up who you are, is navigating the curved geometry of space-time, the beating of your heart, the firing of neurons in your brain, the gentle rise and fall of your chest as you breathe. All of these processes are unfolding within the elegant mathematical landscape of curved four-dimensional space-time, and perhaps most beautifully, this geometric understanding of gravity connects you to everything else in the universe. The same curvature of space-time that you experience as weight also guides the motion of distant galaxies, the orbit of planets around other stars, the dance of binary black holes billions of light years away. You are not separate from the cosmos. You are woven into its very fabric, following the same geometric principles that govern the largest and smallest structures in the universe, from the quantum foam at the Planck scale to the cosmic web of galaxy clusters. You are part of a single, unified geometric reality. This understanding transforms our relationship with the universe around us. We're not isolated objects being pushed and pulled by external forces. Instead, we're integral parts of a vast interconnected geometric structure, each following our own unique path through the curves and contours of space-time. So as you drift towards sleep tonight, remember that the sensation of sinking into your mattress, the feeling of being gently held by gravity, is actually your direct personal experience of the curvature of space-time itself. You're not being pulled down instead. You're being prevented from following your natural straight line motion through the four-dimensional geometry of reality. In this view, every moment of rest, every peaceful breath becomes a meditation on the profound geometric nature of existence. You're not fighting against gravity. You're flowing with the natural curvature of space time itself, and the universe is not pushing or pulling you. It's simply providing the elegant mathematical landscape through which you move. This geometric understanding of gravity leads us to one of the most mind bending realizations in all of physics. If gravity is indeed the curvature of space time rather than a force, then what we call gravitational waves becomes something far more extraordinary than ripples of force traveling through space. They become literal waves in the fabric of reality itself, stretches and compressions in the very dimensions that make up our universe. When two massive objects, like black holes, spiral around each other, they don't just disturb some gravitational field, they actually cause space and time themselves to ripple outward like waves on a pond. These aren't waves traveling through space time, they are waves of space time. The medium and the message are one and the same. Imagine trying to explain to someone that the very stage upon which all of reality plays out can itself wave and undulate. It's rather like discovering that the theater you're sitting in isn't solid and fixed, but is actually made of some flexible material that can stretch and compress, carrying waves from the performance on stage to your seat. Except in this case, you're not just in the theater, you are part of the theater, woven into its very fabric. This revelation becomes even more profound when we realize that these gravitational waves have been detected. Using instruments so sensitive they can measure changes in distance smaller than a thousandth the width of a proton, scientists have observed space-time itself stretching and compressing as these waves pass through Earth. In those moments of detection, we're not just observing some distant cosmic event, we're feeling the universe itself breathing. But let's step back from these cosmic scales and consider what this geometric view means for the most intimate aspects of your existence. Right now, as you listen to these words, the atoms in your body are following geodesics through curved spacetime. The chemical reactions that power your thoughts, the electrical signals traveling through your nervous system, the very process by which your brain constructs your sense of self, all of these are unfolding within the curved geometry of space-time. This means that consciousness itself, whatever that mysterious phenomenon might be, is intimately connected to the geometric structure of reality. Your thoughts aren't just happening in space and time, they're happening as part of the dynamic, curved, ever changing landscape of space time itself. In a very real sense, you don't just exist within the universe, you are a temporary pattern in the universe's ongoing geometric evolution. This perspective transforms how we might think about time as well. In our everyday experience, time feels like a flowing river carrying us from past to future. But in the geometric view of gravity, time is simply one dimension of the four-dimensional space-time manifold. Past, present, and future all exist as different locations along the time dimension, just as here and there exist as different locations along the spatial dimensions. This doesn't mean that time travel becomes possible or that the future is predetermined. Rather, it suggests that our experience of time as flowing might be another kind of illusion, similar to our experience of gravity as a pulling force. What we interpret as the passage of time might actually be our consciousness moving along its world line through the four-dimensional geometry of space-time. Consider this carefully. Every moment of your life, from your birth to this very instant, exists as a point along your personal path through space-time. Your world line, as physicists call it, is like a thread woven through the four-dimensional fabric of reality. What you experience as now is simply your current location along this thread, but the entire thread exists within the geometric structure of space-time. This view suggests something beautiful and perhaps comforting about the nature of existence. Every moment of joy, every instant of love, every peaceful breath you've ever taken exists forever as part of the geometric structure of space-time. They don't disappear into some irretrievable past. They remain as permanent features of the universe's four-dimensional landscape. But this geometric understanding of gravity and space-time also reveals something deeply mysterious about the nature of reality itself. If space-time can curve, if it can wave, if it can be dynamic and flexible, then what exactly is it made of? This question pushes us toward one of the deepest puzzles in modern physics. Some theories suggest that space-time itself might be emergent, arising from more fundamental quantum processes. Just as the smooth surface of water emerges from the chaotic motion of countless molecules, the smooth curvature of space-time might emerge from quantum fluctuations at scales so small we can barely imagine them. At these microscopic scales, space and time might not be continuous at all. Instead, they might be made up of discrete, indivisible units, like pixels in a cosmic computer screen. The smooth geometry we observe at large scales would then be like a digital photograph, appearing continuous from a distance, but revealing its pixelated nature when examined closely enough. This possibility leads to one of the most profound questions we can ask about reality. If space and time are not fundamental, if they emerge from something more basic, then what is that something? What is the deepest level of reality from which space, time, matter, and energy all arise? Some physicists propose that information might be more fundamental than space-time itself. In this view, the universe might be like a vast computation, with space-time and everything within it, emerging from the processing of pure information. The curvature of space-time would then be a consequence of how this cosmic computation organizes and processes information about the distribution of matter and energy. Others suggest that quantum entanglement, the mysterious connection that can exist between particles, regardless of their separation, might be the fundamental ingredient from which space-time emerges. In this picture, the geometry of space-time would be a reflection of the pattern of quantum correlations between microscopic degrees of freedom. These ideas stretch our understanding to its limits and beyond. They suggest that our geometric understanding of gravity, revolutionary as it is, might still be describing shadows cast by an even deeper reality. We've moved from thinking of gravity as a force to understanding it as geometry, but we might need to move once more from geometry to something even more fundamental. Yet even as these mysteries deepen, the geometric understanding of gravity remains one of the most beautiful and elegant ideas in all of science. It transforms our relationship with the universe from one of separation to one of intimate connection. You're not an isolated object being acted upon by external forces. You're an integral part of the universe's geometric structure, following your own unique path through the curves and contours of spacetime. This understanding also reveals the profound interconnectedness of all things. The curvature of spacetime created by distant stars affects the path you follow through the universe. The motion of your body as you shift in your bed creates tiny ripples in space-time that propagate outward at the speed of light. Every heartbeat, every breath, every thought contributes to the ever-changing geometric landscape of reality. In this view, the universe becomes a vast, interconnected, dynamic geometric sculpture with every particle of matter and every quantum of energy contributing to its shape. You're not just observing this sculpture from the outside, you're part of it, helping to create its form through your very existence. This perspective invites a kind of cosmic humility. We're not the masters of a mechanical universe, controlling it through our understanding of forces and laws. Instead, we're participants in a geometric dance that's far grander and more subtle than we ever imagined. We follow the curves of space-time, but through our presence, we also help create those curves. As you contemplate these ideas, notice how they change your relationship with the sensation of gravity. That gentle pressure you feel against your mattress, that sense of being held by the earth, is no longer just a simple downward pull. It's your direct, personal experience of the curvature of four-dimensional space-time. You're feeling the shape of reality itself. This realization connects you to every other conscious being in the universe. Every creature that has ever felt the sensation of weight, from the tiniest insect to the largest whale, has experienced the same fundamental phenomenon, the curvature of space-time. It's a shared experience that transcends species, planets, and even galaxies. And perhaps most remarkably, this geometric understanding suggests that the universe has a kind of memory built into its very structure. Every event that has ever occurred has left its mark on the geometry of space-time. The gravitational waves from ancient cosmic collisions are still propagating through space, carrying information about events that happened billions of years ago. The curvature created by long-dead stars continues to influence the motion of light and matter today. In this sense, the universe is like a vast library, with its history written in the curves and ripples of space-time itself. Every moment contributes to this ongoing story, adding new chapters to the geometric narrative of existence. Your life, your thoughts, your very presence in this moment becomes part of this cosmic autobiography. So as you prepare to drift into sleep, remember that you're not just resting in a bed on a planet in space. You're following your world line through the four-dimensional geometry of space-time, contributing your own unique thread to the vast tapestry of reality. The sensation of falling asleep, that gentle transition from waking consciousness to dream, might itself be a journey through different regions of the geometric landscape of your mind. And in your dreams tonight, as your consciousness creates its own temporary geometries of meaning and memory, you'll be participating in the universe's ongoing exploration of what it means to exist, to be aware, to experience the profound mystery of being a pattern of information and energy woven into the very fabric of space and time. The implications of this geometric view extend far beyond abstract physics into the very core of how we understand existence itself. Consider for a moment that if gravity is indeed an illusion created by curved space time, then many of our most fundamental assumptions about reality need to be reconsidered. The very notion of up and down, of falling and rising, of weight and weightlessness, all become relative descriptions of our motion through curved four dimensional geometry. This brings us to perhaps one of the most beautiful consequences of understanding gravity as geometry rather than force. In the traditional view, massive objects like stars and planets are constantly working against gravity, burning fuel, or generating internal pressure to avoid collapse. But in the geometric view, these objects aren't fighting against anything at all. They're simply existing within the curved space-time that their own mass creates, following the natural contours of reality itself. A star doesn't struggle against gravitational collapse in the way we might imagine someone struggling against a heavy weight. Instead, the star exists in a state of dynamic equilibrium within its own curved space-time geometry. The nuclear fusion in its core creates outward pressure that balances the inward curvature of space-time, like a perfect geometric dance between matter, energy, and the shape of reality itself. This perspective transforms our understanding of cosmic phenomena in profound ways. Black holes, those mysterious objects from which not even light can escape, become less like cosmic vacuum cleaners, sucking in everything around them, and more like regions where space time curvature becomes so extreme that all geodesics lead inward. Nothing is being pulled into a black hole. Rather, the geometry of space time near a black hole is such that all possible paths through space time curve back toward the center. Imagine trying to walk in a straight line on a surface that curves so steeply that no matter which direction you start walking, you always end up at the bottom of a deep waltz. This is analogous to what happens near a black hole, except instead of walking on a curved surface, objects are following geodesics through extremely curved four dimensional space-time. Even light, which has no mass and experiences no gravitational force in the traditional sense, follows these curved geodesics. When we observe light bending around massive objects, we're not seeing a force acting on the light. We're seeing light following the straightest possible path through curved space-time. The light is doing exactly what it always does, traveling in straight lines, but the geometry of space-time itself determines what constitutes a straight line. This understanding also reveals something remarkable about the speed of light. In flat, uncurved space-time, light travels at its familiar speed of roughly 300,000 kilometers per second. But in curved space-time, while light always travels along geodesics, the geometry itself can affect how we measure that speed from different perspectives. Time itself runs differently in curved space-time, which means that our measurements of speed, which depend on both distance and time, become relative to our position within the geometric landscape. For you, lying there listening to these words, this means that time is passing at a slightly different rate than it would if you were floating in empty space, far from any massive objects. The Earth's mass curves space-time around you, and one consequence of this curvature is that time runs slightly slower here than it would in completely flat space-time. The difference is tiny, utterly imperceptible in your daily life, but it's real and measurable. This time dilation effect becomes more pronounced as we approach more massive objects or regions of more extreme space-time curvature. Near a black hole, time would appear to slow dramatically relative to distant observers. This isn't because some force is acting on clocks, but because time itself is part of the geometric structure that becomes increasingly curved in the presence of massive objects. The relationship between space and time in this geometric view is intimate and inseparable. They're not separate entities that happen to be related. They're aspects of a single four-dimensional geometric structure. When space curves, time curves with it. When massive objects create gravitational effects, they're simultaneously affecting both the spatial and temporal dimensions of reality. This unified nature of space time helps explain some of the most puzzling aspects of our universe. The expansion of space itself, the stretching of the cosmic fabric that carries distant galaxies away from us, is not objects moving through space, but space itself evolving geometrically over time. The universe isn't expanding into something. Rather, the geometric structure of space-time itself is changing, growing, evolving. In this context, you exist not just at a particular location in space at a particular moment in time, but at a specific point in the evolving four-dimensional geometry of space-time. Your world line, that thread representing your path through space-time, is woven into a cosmic tapestry that is itself growing and changing. Every breath you take occurs within this dynamic, expanding, geometrically evolving universe. The profound interconnectedness this reveals is breathtaking. The expansion of space affects the geometry around you, though imperceptibly. The motion of distant galaxies contributes to the overall geometric structure within which you exist. The formation of stars billions of light years away sends gravitational waves through space-time that pass through your body, causing it to stretch and compress by amounts smaller than the nucleus of an atom. You are not separate from these cosmic processes. You are embedded within them. The calcium in your bones was forged in the hearts of ancient stars whose gravitational influence helped shape the large-scale structure of the universe. The iron in your blood carries the geometric signature of supernovas that exploded billions of years ago, their gravitational waves still propagating through the cosmos. This geometric view also transforms our understanding of what it means to be at rest. In the traditional view, you might think of yourself as sitting still when you're lying in bed. But in the geometric view, there's no such thing as absolute rest. You're always moving through space-time, following your world line through the four-dimensional manifold. Even when you're perfectly still in space, you're still moving through time, and this motion through time is as real and fundamental as motion through space. Your world line through space-time has a kind of speed associated with it, but it's not the kind of speed you might normally think about. In four-dimensional space-time, all objects, including you, move through space-time at the speed of light. When you're at rest in space, all of your motion through space-time is motion through time. When you move through space, some of your motion through time gets converted into motion through space, but the total remains constant. This means that motion through space actually slows down your motion through time, which is why moving clocks run slow relative to stationary ones. It's not that motion affects clocks, it's that motion through space necessarily means less motion through time, and clocks measure motion through time. These concepts stretch our intuition to its limits and beyond. We evolved to navigate a world of solid objects and simple motions, not four-dimensional curved geometries. Yet this geometric reality underlies every aspect of our existence. The beating of your heart occurs within curved space-time. The firing of neurons in your brain follows geodesics through the geometric landscape of reality. Even the quantum processes that might underlie consciousness itself unfold within this curved four-dimensional stage. Perhaps most remarkably, this geometric understanding suggests that the universe has a kind of memory encoded in its very structure. Every massive object that has ever existed has left its mark on the geometry of space-time. The gravitational waves from cosmic events billions of years ago are still propagating through space, carrying information about the universe's history in the ripples of space-time itself. Ancient collisions between black holes, the explosive deaths of massive stars, the formation and evolution of galaxies, all of these events continue to influence the geometric structure of space-time today. The universe remembers its history not in some abstract sense, but literally in the ongoing pattern of curvature and wave propagation that makes up the fabric of reality. You exist within this living memory of the cosmos. The space-time around you carries information about every significant event that has ever occurred within the observable universe. The geometry through which you move has been shaped by the entire history of cosmic evolution, from the first moments after the Big Bang to the formation of the very atoms that make up your body. This perspective reveals existence as participation in an ongoing cosmic story written in the language of geometry. You're not just observing the universe from some external vantage point, you're contributing to its geometric evolution through your very presence. Your mass, tiny as it is on cosmic scales, creates its own subtle curvature in space-time. Your motion through space-time generates gravitational waves, infinitesimally small but real, that propagate outward at the speed of light. In this view, consciousness becomes something even more mysterious and wonderful than we might have imagined. Whatever consciousness is, wherever it comes from, it arises within and participates in this vast geometric dance of space-time. Your thoughts, your dreams, your sense of self all emerge from patterns of matter and energy following geodesics through curved four-dimensional space-time. The question of whether consciousness might itself influence the geometry of space-time remains at the frontier of both physics and philosophy. Some theories suggest that the act of observation, the collapse of quantum possibilities into definite outcomes, might have subtle effects on the geometric structure of reality itself. If true, this would mean that consciousness doesn't just exist within space-time, but participates in shaping its geometry. As you contemplate these extraordinary possibilities, notice how your understanding of the simple act of lying still continues to evolve. You're not merely resting on a solid surface under the influence of a downward force. You're following a geodesic through curved space-time, with the surface beneath you preventing you from continuing along your natural path. The sensation of weight, of being pressed gently into your mattress, is your direct experience of this geometric interaction. But even this description might not capture the full depth of what's occurring. If space-time itself emerges from more fundamental processes, then your experience of lying still might be your participation in the universe's ongoing exploration of its own deepest nature. Every moment of rest, every breath, every heartbeat might be the cosmos investigating what it means to exist, to be aware, to experience the profound mystery of being. This brings us to perhaps the most profound implication of understanding gravity as geometric rather than force based. It suggests that the universe is not a collection of separate objects interacting through forces, but a single, unified, dynamic geometric structure. You don't exist within this structure as a foreign object. You are part of the structure itself, a temporary pattern in the ongoing geometric evolution of reality. In this view, the boundaries between self and universe, between observer and observed, between mind and matter, become fluid and perhaps ultimately illusory. You are not separate from the curved space-time you move through. You are a manifestation of its geometric complexity. Your consciousness is not separate from the physical processes of your brain. It might be how certain geometric patterns in space time experience themselves. This perspective invites a profound shift in how we relate to existence itself. Instead of seeing ourselves as isolated beings struggling against external forces, we can understand ourselves as expressions of the universe's geometric creativity. Instead of fighting gravity, we can appreciate that we're dancing with the curvature of space time itself. So, as you prepare to drift into sleep, remember that this transition from waking consciousness to dream is itself a journey through the geometric landscape of your mind. The neural processes that create your dreams follow the same fundamental geometric principles that govern the motion of planets and the propagation of light. Your sleeping brain will create its own temporary geometries of meaning and memory, its own curved spaces of narrative and symbol. And in those dreams, as your consciousness explores landscapes that exist only in the geometric patterns of neural activity, you'll be participating in the universe's ongoing investigation of what it means to be aware, to experience, to exist as a pattern of information and energy woven into the very fabric of space and time itself. Sweet dreams await you in the gentle curves of space-time, where even rest becomes a kind of cosmic choreography. But before we drift too far into the realm of sleep, there's one more layer to this beautiful illusion we call gravity that deserves our quiet contemplation. You see, the story we've been exploring tonight, this revelation that gravity might be geometry rather than force, opens doors to some of the most profound questions we can ask about the nature of reality itself. Consider for a moment what it means to say that massive objects curve space-time. We've spoken of this curvature as if it were something we could visualize, like the depression a bowling ball makes in a stretched rubber sheet. But this analogy, helpful as it is, barely scratches the surface of what's actually happening. The curvature we're describing isn't happening in some external dimension that we can step outside of and observe. It's happening within the very fabric of reality itself, within the four-dimensional stage upon which all of existence plays out. This brings us to one of the most beautiful paradoxes in all of physics. How can we, as beings embedded within space-time, hope to understand the curvature of space-time itself? It's rather like asking a character in a novel to step outside the book and examine the pages upon which their story is written. We are part of the geometric structure we're trying to understand, woven into the very fabric we're attempting to describe. And yet, Somehow, through the miracle of mathematics and careful observation, we've managed to do exactly that. We've found ways to measure the curvature of our own reality from within. We've detected the stretching and compressing of space time as gravitational waves pass through our detectors. We've observed light bending around massive objects, following the curves we cannot directly see. We've measured time running at different rates in different gravitational environments, revealing the intimate connection between matter, geometry, and the flow of time itself. This achievement represents something truly extraordinary about consciousness and intelligence. Here you are, a temporary pattern of atoms and energy, following geodesics through curved space-time, and yet somehow capable of understanding the very geometric principles that govern your own existence. Your brain, composed of matter that obeys these geometric laws, has developed the capacity to comprehend those laws. It's as if the universe has become sufficiently complex to begin understanding itself. But this understanding comes with a humbling recognition of how much remains mysterious. Even as we celebrate the elegance of describing gravity as geometry, we must acknowledge that we still don't know why mass and energy curve space-time in the first place. We have Einstein's field equations, those beautiful mathematical expressions that relate the geometry of space-time to the distribution of matter and energy within it. But these equations describe the relationship without explaining why such a relationship should exist at all. Why should the presence of matter tell space-time how to curve? Why should the curvature of space-time tell matter how to move? These questions point towards something even deeper than our geometric understanding of gravity. They suggest that beneath the elegance of curved space-time lies another layer of mystery, another level of reality that we've only begun to glimpse. Some of the most intriguing possibilities emerge when we consider what happens at the smallest possible scales of space and time. At these quantum scales, the smooth curvature we observe in our everyday world might give way to something far stranger and more fundamental. Space-time itself might become granular, made up of discrete units so small that they make atoms look like boulders by comparison. If this is true, then the flowing curves of space-time that we've been describing might be like the smooth surface of water, appearing continuous from a distance, but revealing its atomic structure when examined closely enough. The gravitational waves that ripple through space-time might be like sound waves in water, emergent phenomena that arise from the collective behavior of countless microscopic components. This quantum perspective on space-time leads to some truly mind-bending possibilities. Perhaps the geometry of space-time itself fluctuates and foams at the smallest scales, constantly creating and destroying tiny bubbles of curved space. Perhaps what we experience as the smooth passage of time emerges from the quantum ticking of some cosmic clock, each tick corresponding to the smallest possible unit of temporal existence. In this view, your experience of lying peacefully in bed, following your world line through curved space-time, might be built up from an incomprehensibly vast number of quantum geometric processes. Every moment of your existence, every heartbeat, every thought might emerge from the collective behavior of quantum space-time foam, like consciousness arising from the dance of subatomic geometry. But even these quantum speculations might not represent the deepest level of reality. Some of the most revolutionary ideas in modern physics suggest that space-time itself, whether smooth or quantized, might be emergent from something even more fundamental. Perhaps the four-dimensional geometric stage upon which all of physics plays out is itself a kind of hologram, a projection from information encoded on some distant boundary. In this holographic view of reality, everything you experience, including the sensation of gravity and the curvature of space-time itself, might be like the image projected by a hologram. The real information, the fundamental description of reality, might exist in a completely different form, on a boundary that exists in fewer dimensions than the spacetime we experience. This possibility suggests that the geometric understanding of gravity, revolutionary as it is, might still be describing shadows cast by an even deeper reality. We've moved from forces to geometry, but we might need to move once more from geometry to pure information, from curved space-time to patterns of quantum entanglement, from physical reality to something that transcends our current understanding of what it means for something to exist. These ideas stretch our comprehension to its absolute limits and beyond. They suggest that the universe might be far stranger, far more subtle, far more beautiful than even our most imaginative theories can capture. They remind us that for all our progress in understanding the cosmos, we might still be like children playing on the shore of an infinite ocean of mystery. Yet there's something deeply comforting about this endless depth of mystery. It means that the universe will always have more to teach us, always have new wonders to reveal. It means that the sense of awe and curiosity that brought you to this exploration tonight will never be exhausted, never reach a final answer that closes off further questioning. And perhaps that's as it should be. Perhaps the greatest gift the universe gives us is not final answers, but ever deeper questions, not ultimate truth, but an endless journey of discovery. Perhaps consciousness itself exists not to solve the mystery of existence, but to participate in it, to be the universe's way of experiencing its own infinite creativity and depth. As you lie there, contemplating these extraordinary possibilities, notice how your relationship with the simple act of existing continues to evolve. You're not just a collection of atoms held together by chemical bonds. You're not just a biological organism following evolutionary imperatives. You're not even just a pattern of information processing in a complex neural network. You are something far more mysterious and wonderful. You are a temporary constellation of matter and energy, following geodesics through the curved geometry of spacetime, participating in the universe's ongoing exploration of its own nature. You are consciousness arising from quantum processes that might themselves emerge from even deeper levels of reality that we can barely imagine. Your thoughts right now, as you listen to these words, represent the universe becoming aware of itself. Your capacity for wonder, for questioning, for seeking understanding is the cosmos developing the ability to contemplate its own existence. In a very real sense, when you ponder the nature of gravity and space-time, you are the universe thinking about itself. This realization transforms the very act of learning, of seeking to understand the world around us. It's not that we, as separate beings, are discovering facts about an external universe. Rather, we are the universe discovering itself, consciousness emerging from complexity, understanding arising from the geometric dance of matter and energy through curved spacetime. Every moment of curiosity, every question that arises in your mind, every flash of insight or understanding represents the cosmos exploring its own infinite depths. When you feel that sense of wonder at the idea that gravity might be an illusion created by curved spacetime, that wonder is the universe marveling at its own elegant mathematical structure. This perspective suggests that the pursuit of knowledge, the drive to understand how things work, is not just a human peculiarity, but a fundamental feature of reality itself. The universe seems to be inherently curious about itself, constantly exploring new possibilities, new forms of organization, new ways of experiencing and understanding existence. From the formation of the first atoms in the early universe to the emergence of life on Earth, from the development of consciousness to the creation of science and mathematics, the cosmos appears to be on a journey of self discovery, and you, lying there in the gentle embrace of curved space time, are part of that journey. You are the universe's current best attempt at understanding itself. This understanding brings with it a profound sense of responsibility and privilege. If you are indeed the cosmos becoming aware of itself, then your thoughts, your questions, your sense of wonder and curiosity all contribute to the universe's ongoing project of self exploration. Every moment of genuine learning or insight represents a small victory in the cosmic quest for self understanding. But it also brings a deep sense of connection and belonging. You are not an accident, not a random collection of atoms that happen to stumble into existence. You are the inevitable result of the universe's inherent tendency toward greater complexity, greater consciousness, greater understanding. You belong here not as a visitor to reality, but as one of its most remarkable expressions. This belonging extends to every aspect of your existence, including the most mundane. The sensation of weight that you feel right now, that gentle pressure against your bed or chair, connects you to every other massive object in the universe. The same geometric principles that create your sense of weight also govern the orbit of planets, the formation of galaxies, the collision of black holes billions of light years away. You are part of a vast cosmic community, connected to every star and planet, every black hole and quasar, every particle of dark matter and quantum of energy by the shared geometric structure of space-time. The curvature that gives you weight also guides light from distant galaxies to your eyes, allowing you to see deep into space and far back in time. When you look up at the night sky, you're not just observing distant objects, you're seeing the geometric structure of the universe itself, the pattern of curvature created by billions of years of cosmic evolution. The light from those distant stars has followed geodesics through curved space-time to reach you, carrying information about the geometric landscape of the cosmos. In this sense, every act of observation is an act of geometric exploration. When you see a star, you're tracing the path that light has taken through the curved space-time between that star and your eye. When you feel the pull of gravity, you're experiencing the local curvature of space-time created by the Earth's mass. When you watch the sun set, you're observing the rotation of the Earth within the geometric framework established by the sun's gravitational influence. These everyday experiences, so familiar that we usually take them for granted, become profound encounters with the fundamental structure of reality when viewed through the lens of geometric gravity. Every moment of your existence is a direct, intimate experience of the curvature of four-dimensional space-time. This intimacy between your consciousness and the geometric structure of reality suggests something beautiful about the nature of existence itself. You are not separate from the universe you seek to understand. You are not an external observer studying reality from some detached perspective. You are reality experiencing itself, space time becoming aware of its own curvature, the cosmos developing the capacity for self reflection. This unity between observer and observed, between consciousness and cosmos, between mind and geometric reality, points toward a deeply interconnected universe where the boundaries we normally draw between self and world, between inner and outer, between subjective and objective, become fluid and ultimately perhaps illusory. In this view, the question of whether gravity is a force or an illusion becomes part of a larger question about the nature of all our experiences. Perhaps everything we perceive, from the sensation of weight to the feeling of solidity, from the passage of time to the experience of consciousness itself, represents our interpretation of deeper geometric and quantum processes that lie beneath the surface of ordinary experience. Just as gravity emerges from the curvature of space-time, perhaps consciousness emerges from the complex geometric patterns of neural activity in your brain. Just as the sensation of weight is your interpretation of geodesic motion through curved space-time, perhaps all of your experiences are interpretations of underlying physical processes that are far stranger and more beautiful than they appear. This suggests that the journey we've taken tonight, from thinking of gravity as a simple downward pull to understanding it as the curvature of four-dimensional space-time, might be just the beginning of a much larger transformation in how we understand reality itself. Every aspect of existence might reveal similar depths when examined closely enough, similar layers of beauty and mystery hidden beneath familiar surfaces. As you prepare to drift into sleep, carry with you the sense of infinite depth, this recognition that reality is far more mysterious and wonderful than it appears. The dreams that await you will unfold within the same geometric landscape we've been exploring, created by neural processes that follow the same fundamental principles that govern the motion of planets and the propagations of light. In your dreams tonight, you'll create temporary worlds, impossible architectures, stories that unfold outside the normal constraints of space and time. These dream worlds, fleeting as they are, represent the same creative principle that built the universe itself, the same tendency toward complexity and beauty that created stars, planets, life, and consciousness. And when you wake tomorrow morning, you'll return to this waking dream we call reality, this extraordinary geometric landscape where gravity curves space-time, where consciousness emerges from complexity, where the universe continues its eternal project of understanding itself through beings like you. The sensation of waking up, of returning to normal awareness of your body and your surroundings, will be another encounter with the curvature of space-time, another moment of the cosmos experiencing itself through the miracle of consciousness. The simple act of getting out of bed will be a dance with geometry, a graceful movement through the curved four-dimensional landscape that underlies all of existence. So rest now, knowing that even in sleep, you remain part of this grand geometric adventure. Your dreams will be new explorations of possibility, new ways for the universe to experience and understand itself. And your peaceful rest will be another form of the cosmic dance, another way of participating in the ongoing mystery of existence. Sweet dreams, fellow traveler through the curved corridors of spacetime. May your rest be deep, your dreams be wondrous, and your awakening be filled with continued curiosity about the beautiful illusions and deeper realities that surround us always. The gentle mysteries we've explored tonight lead us to one final contemplation, one that might transform how you experience not just gravity, but every moment of your existence. You see, if gravity truly is an illusion born from curved space time, then we must ask ourselves what else might be masquerading as something it's not. What other fundamental aspects of reality might reveal deeper truths when examined with the same careful attention we've given to the sensation of weight? Consider the very notion of falling asleep that awaits you. In our everyday understanding, sleep seems like a simple transition from one state to another, consciousness gradually fading as your brain settles into rest. But just as gravity revealed itself to be geometry rather than force, sleep too might be something far more extraordinary than it appears. The neural processes that will soon carry you into dreams don't simply shut down your awareness, they transform it. Your brain doesn't merely reduce its activity during sleep, it reorganizes itself in ways that are still deeply mysterious to science. The same organ that right now is contemplating the curvature of space time will soon create entire worlds that exist nowhere but in the geometric patterns of electrical activity flowing through your neural networks. These dream worlds will feel completely real while you experience them, with their own internal logic, their own physics, their own emotional landscapes. Yet they emerge from nothing more than the coordinated firing of neurons, following the same fundamental laws that govern everything else in the universe. In a sense, your dreaming brain becomes a kind of pocket universe, creating temporary realities that exist within the larger reality of curved space-time. This parallel between the illusion of gravity and the illusion of solid, separate dream realities points towards something profound about the nature of consciousness itself. Just as objects aren't really being pulled by gravitational force, but are following geodesics through curved geometry, perhaps consciousness isn't really contained within your skull, but is a pattern that emerges from the complex interactions between your brain and the geometric landscape of space-time itself. Think about what happens when you remember something from your past. Where does that memory exist? It's not stored in any single location in your brain like a file on a computer hard drive. Instead, it emerges from the coordinated activity of millions of neurons, a pattern that exists only when it's being activated. In a very real sense, your memories exist in the geometry of neural connections, in the curved pathways that electrical signals trace through your brain tissue. But your brain tissue is made of atoms, and those atoms exist within the curved space-time we've been exploring. The electrical signals that carry your thoughts follow paths determined by the molecular structure of your neurons, which in turn exists within the four-dimensional geometric framework of reality itself. In this view, consciousness becomes not something separate from the physical universe, but a particular kind of geometric pattern within it. This understanding suggests that the boundary between your inner mental world and the outer physical universe might be far more porous than we usually imagine. The thoughts you're thinking right now as you listen to these words exist as patterns of electrical activity in your brain, but that brain exists within curved space time, and those electrical patterns are themselves manifestations of quantum processes that are woven into the very fabric of reality. Perhaps consciousness, like gravity, is not what it appears to be. Instead of being a private, internal phenomenon locked away inside your head, it might be a way that certain patterns of matter and energy within curved space time experience themselves. Your sense of being a separate self, distinct from the world around you, might be as much an illusion as the sensation of being pulled downward by gravitational force. This possibility becomes even more intriguing when we consider that the atoms in your body were forged in the nuclear furnaces of ancient stars. The carbon in your cells, the oxygen you breathe, the iron in your blood, all of these elements were created in stellar cores and scattered through space when those stars exploded in supernovae billions of years ago. You are quite literally made of stardust, assembled from materials that have been cycling through the cosmos since long before the Earth formed. But it's not just that your body is made of stellar material. The very space time through which those atoms traveled to eventually become part of you carries the gravitational memory of every massive object they've ever encountered. The curvature of space time around you has been shaped by the entire history of the universe, from the first moments after the Big Bang to the formation of the galaxy that contains our solar system. In this sense, you don't just exist within the universe, you are a temporary focal point where the universe's history converges. Every breath you take draws in atoms that have been part of countless other structures throughout cosmic history. Every heartbeat pumps elements through your body that were present at the birth of stars, that witnessed the formation of planets, that participated in the complex chemistry that gave rise to life itself. Your consciousness, whatever it ultimately is, emerges from this convergence of cosmic history. The neural networks that generate your thoughts and experiences are built from materials that carry within their very structure the story of the universe's evolution. When you contemplate the curvature of space-time, you are the cosmos contemplating itself through patterns of matter and energy that have been shaped by billions of years of gravitational interaction. This perspective transforms the simple act of lying down to sleep into something almost ceremonial. You're not just resting your individual body, you're allowing a particular configuration of cosmic material to settle into a state of peaceful restoration. The atoms that make up your muscles and bones will spend the night following their geodesics through curved space-time while your consciousness dances through dream landscapes that exist in the geometric patterns of neural activity. The boundary between sleeping and waking, like the boundary between self and universe, becomes fluid when viewed from this cosmic perspective. Your waking consciousness emerges from the same fundamental processes that will soon create your dreams. Both states represent different ways that the universe experiences itself through the temporary pattern of organization we call your body and brain. Even the transition itself, that gentle drift from awareness to sleep, becomes a kind of geometric transformation. As your neural activity shifts from the patterns associated with waking consciousness to those of sleep, you're not just changing mental states, you're participating in the universe's ongoing exploration of different forms of self organization and self experience. The dreams that await you will be new experiments in consciousness, new ways for matter and energy to organize themselves into patterns capable of experience and awareness. In your dreams, the universe will create temporary worlds with their own physics, their own narratives, their own emotional textures. These dream worlds may seem less real than waking reality, but they emerge from the same fundamental geometric processes that create everything else in the cosmos. Perhaps most remarkably, the fact that you can understand these ideas at all, that patterns of matter organized into a human brain can contemplate the nature of space time and consciousness, represents one of the universe's greatest achievements. Through billions of years of evolution, the cosmos has created structures complex enough to understand their own foundations, conscious enough to marvel at their own existence. You are not just observing the universe from some external vantage point, you are the universe observing itself. Your capacity for wonder, for questioning, for seeking deeper understanding is the cosmos developing the ability to appreciate its own extraordinary nature. Every moment of genuine curiosity or insight represents the universe celebrating its own elegant mathematical structure. This realization brings with it both humility and a kind of cosmic dignity. You are simultaneously insignificant, a tiny temporary pattern in a vast universe, and utterly central, the very mechanism by which the cosmos comes to know itself. Your thoughts matter because they are literally the universe thinking. Your experiences matter because they are reality experiencing itself. The sensation of weight that gently holds you as you prepare for sleep is not just your personal encounter with curved space time. It's the universe feeling its own geometric structure through your awareness. The peace that settles over you as consciousness begins to fade is not just your individual rest, it's the cosmos enjoying a moment of quiet contemplation through your experience. In this view, sleep becomes not an escape from reality, but a deeper participation in it. As your waking consciousness dissolves into the strange landscapes of dream, you're not leaving the universe behind. You're exploring new regions of its infinite creativity. The stories your mind will weave during sleep are new chapters in the cosmic narrative of self discovery. And when morning comes, when you return to waking awareness and feel once again that familiar sensation of weight pressing you gently into your bed, you'll be experiencing another moment of the universe's ongoing encounter with its own nature. The simple act of opening your eyes and returning to ordinary consciousness will be the cosmos awakening to itself once more. So rest now, knowing that your sleep is not a withdrawal from the grand adventure of existence, but a continuation of it in a different key. Let yourself sink into the gentle embrace of curved space-time, following your world line through the four-dimensional landscape of reality. Your dreams await in the geometric gardens of consciousness, where the universe continues its eternal exploration of what it means to be aware, to experience, to exist as pattern and possibility woven into the very fabric of space and time. The illusion of gravity that holds you gently in its geometric embrace is no less beautiful for being an illusion. Like consciousness itself, like the sensation of being a separate self, like the feeling of weight and solidity and the passage of time, it represents the universe's extraordinary capacity to experience itself in countless different ways. You are one of those ways, a temporary but precious method by which the cosmos comes to know and appreciate its own infinite mystery. Sweet dreams, fellow pattern in the cosmic dance. May your rest be deep, your dreams be wondrous, and your awakening tomorrow be filled with continued awe at the beautiful illusions and deeper realities that surround us always. In the gentle curves of space-time, even gravity becomes a lullaby, singing the universe to sleep with the soft mathematics of existence itself. But what happens when we push this understanding even further? When we ask not just whether gravity is an illusion, but whether our entire experience of physical reality might be something far more subtle than it appears? The geometric view of gravity opens a door to questions that stretch our comprehension to its very limits, questions that might fundamentally alter how we understand existence itself. Consider the peculiar relationship between information and reality that emerges from our exploration of curved space-time. When gravitational waves ripple through the cosmos, carrying news of distant black hole collisions across billions of light years, what exactly is traveling through space? It's not matter in any conventional sense. It's not energy as we normally conceive it. Instead, it's pure geometric information, patterns of curvature that propagate through the fabric of space-time itself. This suggests something profound about the nature of reality. Perhaps at its deepest level, the universe is not made of stuff at all, but of relationships, patterns, information, encoded in the geometric structure of space-time. The atoms in your body, the electrical signals in your brain, even the sensation of weight you feel right now, might all be different ways that underlying geometric information manifests itself in our experience. This information theoretic view of reality leads to some truly extraordinary possibilities. If the universe is fundamentally informational rather than material, then the boundary between what we call physical and what we call mental becomes far more mysterious. Your thoughts, after all, are patterns of information encoded in the neural networks of your brain. But if everything is ultimately information, then consciousness might not be something separate from the physical world, but rather a particular way that information organizes and experiences itself. Imagine reality as a vast computational process, with space-time itself serving as a kind of cosmic computer. The curvature we experience as gravity would then be like the processing of geometric algorithms, calculations performed by the universe itself as it evolves from moment to moment. In this view, every particle interaction, every quantum event, every heartbeat and thought would be steps in an incomprehensibly complex cosmic computation. But what would such a computation be calculating? Perhaps it's exploring every possible configuration of matter and energy, every potential arrangement of information, every conceivable form of organization and awareness. Your existence, your consciousness, your capacity to contemplate these very questions would then represent one particular solution that the universe has discovered in its vast computational exploration of possibility space. This perspective transforms your relationship with time in ways that might seem almost mystical. If reality is computational, then the flow of time you experience might be the universe's way of processing information sequentially, exploring the logical implications of each moment before moving on to the next. Your memories would be stored solutions to previous computational steps. Your dreams would be the universe running alternative calculations, exploring paths not taken in waking reality. The sensation of lying still in bed takes on new meaning in this context. You're not simply resting in curved space-time. You're participating in a cosmic calculation so complex that it requires billions of years to unfold. Every breath you take represents millions of molecular interactions, each one a tiny computational step in the universe's ongoing exploration of chemical possibility. Every neural firing in your brain contributes to the vast parallel processing system that gives rise to your consciousness. But perhaps even more remarkably, this computational view suggests that consciousness itself might be the universe's way of experiencing the results of its own calculations. Through beings like you, the cosmos doesn't just compute, it experiences the meaning and beauty of what it computes. Your capacity for wonder, for aesthetic appreciation, for love and curiosity would then be the universe developing the ability to find its own computational processes beautiful and meaningful. This brings us to one of the most profound questions we can ask about the nature of existence. If reality is fundamentally informational, if consciousness emerges from cosmic computation, if even gravity is geometric information rather than physical force, then what distinguishes the real from the simulated? How would we know if our entire universe, including the curved space-time we've been exploring, is itself running as a computation within some larger reality? These questions aren't merely philosophical speculation. They emerge naturally from taking the geometric understanding of gravity to its logical conclusions. If space-time can be curved, if it can wave, if it can process gravitational information at the speed of light, then it shares many characteristics with what we might call a computational medium. The universe begins to look less like a mechanical system and more like an information processing system of unimaginable sophistication. Your brain, sitting there in curved spacetime, contemplating the nature of curved spacetime, becomes a particularly fascinating example of this cosmic computation. The same geometric principles that govern the orbit of planets also determine how electrical signals propagate through your neural networks. The same mathematical laws that describe black holes also describe the quantum processes that might underlie consciousness itself. This suggests a deep unity between mind and cosmos, between consciousness and geometry, between information and reality. You're not a separate observer studying an external universe. You're a local concentration of the universe's information processing capacity, a region where cosmic computation has become sufficiently complex to contemplate its own nature. The dreams that will soon carry you away from ordinary awareness represent another form of this cosmic computation. As your brain shifts into sleep mode, it doesn't simply shut down, it begins running different algorithms, exploring alternative configurations of memory and meaning. The strange landscapes of dream become testing grounds for consciousness, ways for the universe to experiment with different forms of self organization and self experience. In your dreams tonight, the universe will create temporary realities with their own internal consistency, their own physics, their own emotional logic. These dream worlds emerge from the same computational substrate that creates waking reality, but they follow different rules, explore different possibilities. They represent the cosmos playing with itself, trying out alternative forms of existence, just to see what might be possible. The fact that dreams can feel completely real while you're experiencing them reveals something important about the nature of reality itself. If consciousness can be convinced of the reality of entirely fabricated worlds, then perhaps our certainty about the reality of the waking world deserves more careful examination. Not that waking reality is false, but that the relationship between consciousness and reality is far more complex and mysterious than we usually assume. This complexity becomes even more apparent when we consider the role of observation in quantum mechanics. At the smallest scales of reality, the act of measurement seems to play a crucial role in determining what actually happens. So, before observation, quantum systems exist in superposition, in states of pure possibility. Only when they're observed do they collapse into definite outcomes, into specific realities. If consciousness plays a role in quantum measurement, and if quantum processes underlie all of classical physics, including the curvature of spacetime, then consciousness might participate in creating the very reality it observes. Your awareness, your attention, your act of contemplating these ideas right now might be contributing to the ongoing process by which the universe determines its own nature. This possibility suggests that the illusion of gravity might be part of a much larger illusion, the illusion that consciousness is separate from the reality it observes. Perhaps subject and object, observer and observed, mind and world, are artificial distinctions that break down when we examine them closely enough. Perhaps consciousness and cosmos are aspects of a single, unified, self creating, and self experiencing reality. In this view, your individual consciousness becomes a focal point where the universe experiences itself locally. Your thoughts are the cosmos thinking, your emotions are reality feeling, your dreams are the universe imagining alternative possibilities for itself. The sensation of being a separate self, distinct from the world around you, would then be another beautiful illusion, like gravity itself, that emerges from deeper processes of cosmic self organization. This understanding transforms the simple act of falling asleep into something almost sacred. As consciousness fades and dream awareness begins, you're not withdrawing from reality, but participating in its ongoing creative process. The universe is using your brain to explore new forms of experience, new ways of organizing information, new possibilities for what it might mean to be aware. The transition between waking and sleeping becomes a kind of phase change in cosmic consciousness, like water turning to steam or ice crystallizing from liquid. The same underlying informational substrate continues to exist, but it organizes itself differently, creating different forms of experience and awareness. Your dreams will be new experiments in consciousness, new ways for the universe to know itself. And when you wake tomorrow morning, returning to ordinary awareness of your body in curved space-time, you'll be participating in another phase change, another transformation in the universe's ongoing exploration of its own nature. The sensation of weight returning, of solidity reasserting itself, of time resuming its familiar flow, will be the cosmos settling back into one particular mode of self experience after exploring others. This cyclical dance between different states of consciousness mirrors larger cosmic cycles, the expansion and contraction of space itself, the birth and death of stars, the evolution and dissolution of galaxies. Your personal rhythm of sleeping and waking participates in the universal tendency toward change, growth, exploration, and renewal that characterizes reality at every scale. As you prepare to surrender to sleep, remember that you're not leaving the cosmic adventure behind, but entering a different phase of it. The geometric landscape of curved space-time will continue to exist around your sleeping body, but your consciousness will create its own temporary geometries, its own curved spaces of meaning and narrative. In those dream spaces, the laws of physics might bend in impossible ways. Time might flow backward or sideways. Space might fold in on itself to create miraculous connections between distant places and times. These dream physics aren't violations of cosmic law, but explorations of alternative possibilities, ways for the universe to investigate what might be possible under different conditions. The stories your sleeping mind will weave are new chapters in the cosmic narrative of self discovery, temporary novels written in the language of neural electricity, brief symphonies composed in the medium of consciousness itself. They'll feel completely real while you experience them because they are real, just real in a different way than waking experience. Real as patterns of information rather than configurations of matter. So rest now in the gentle embrace of curved spacetime, knowing that even in sleep, you remain part of the universe's grand computational process. Your dreams will be new algorithms of awareness, new programs running on the cosmic computer of consciousness. And in the morning, when ordinary reality reasserts itself, you'll wake not as someone who has been absent from the universe, but as someone who has been exploring its hidden dimensions. The illusion of gravity that holds you gently in place is no less beautiful for being geometric rather than forceful. Like consciousness itself, like the sensation of selfhood, like the experience of time and space and matter, it represents the universe's extraordinary capacity to create meaningful experiences from pure information, to transform mathematical relationships into felt reality, to be not just a cosmic computer, but a cosmos that experiences the beauty of its own computations. Sweet dreams await in the curved corridors of space-time, where even rest becomes a form of cosmic creativity, where consciousness continues its eternal dance with reality, where the universe dreams new dreams of what it might mean to exist, to be aware, to participate in the ongoing mystery of being itself. Sleep well, knowing that tomorrow you'll wake not just to another day, but to another moment in the universe's ongoing conversation with itself. The morning light that streams through your window will have traveled millions of miles through curved space-time to reach you, carrying with it the geometric signature of our star's gravitational influence. That light will strike your retina and trigger cascades of neural activity that transform electromagnetic radiation into the experience of seeing, another miraculous translation between the mathematical and the meaningful. And as you rise from bed, feeling that familiar sensation of weight settling into your bones, you'll know the deeper truth. You're not being pulled downward by some mysterious force. Instead, you're following the most natural path possible through the curved four-dimensional landscape of existence itself. Every step you take will be a dance with geometry, every breath a participation in the cosmic computation that unfolds moment by moment around us. The coffee you drink will warm your body through molecular vibrations that follow the same fundamental principles governing the collision of galaxies. The thoughts you think will emerge from neural patterns that obey the same geometric laws that shape space-time itself. The love you feel for those close to you will be consciousness recognizing itself in other temporary configurations of cosmic matter and energy. Throughout your day, you'll move through a world where every surface you touch, every sound you hear, every emotion you experience represents the universe's ongoing exploration of its own infinite possibilities. The solid ground beneath your feet will be mostly empty space, held together by electromagnetic forces that are themselves geometric relationships in higher dimensional space. The air you breathe will be molecules dancing through probability clouds, their positions and velocities existing in quantum superposition until the very moment they interact with your lungs. And when evening comes again, when you settle once more into the gentle embrace of curved space-time, you'll carry with you this deeper understanding. Gravity isn't just something that happens to you, it's something you participate in, a geometric relationship between your mass and the curvature of reality itself. You don't just exist within the universe, you are the universe experiencing itself locally, temporarily, beautifully. The questions we've explored tonight don't have final answers, and perhaps that's the most wonderful thing about them. Each layer of understanding we peel back reveals new mysteries beneath, new depths to explore, new ways for consciousness to encounter the infinite creativity of existence. The universe seems designed not to be solved, but to be endlessly discovered, not to reach some final state of complete knowledge, but to continue forever the joyful process of coming to know itself more deeply. In this ongoing cosmic conversation between matter and mind, between geometry and consciousness, between the mathematical and the meaningful, you play an irreplaceable role. Your capacity for wonder, your ability to ask questions about the nature of reality, your sense of awe at the elegant strangeness of existence. These are not accidents or byproducts. They are the universe's way of appreciating its own extraordinary nature. So as consciousness fades and dream takes hold, remember that you're not leaving this cosmic adventure behind. You're simply entering a different phase of it, exploring new territories in the vast landscape of possibility that the universe presents to itself through beings like you. Your dreams will be temporary universes with their own physics, their own stories, their own moments of beauty and meaning. And in those dreams, perhaps you'll fly through impossible architectures, walk on surfaces that curve in ways that defy ordinary geometry, experience time flowing in spirals rather than straight lines. These dream experiences, strange as they may seem, are no less real than waking life in the sense that they emerge from the same fundamental processes of cosmic self-organization and self-experience. The gentle pressure you feel now as your body settles into rest is your direct, intimate encounter with the curvature of four-dimensional space-time. It's the universe holding you gently in its geometric embrace, supporting you not through some external force, but through the elegant mathematical relationships that constitute the very fabric of reality. Rest peacefully in this knowledge. You are exactly where you belong, following exactly the path you should follow, participating exactly as you should in the grand geometric dance of existence. The sensation of weight, the feeling of being held by gravity, is no less beautiful for being an illusion. It's a perfect illusion, an elegant translation of mathematical truth into felt experience, a bridge between the abstract and the intimate. Tomorrow will bring new opportunities to marvel at this strange and wonderful universe we find ourselves woven into. New moments to contemplate the elegant equations that govern everything from the smallest quantum fluctuations to the largest galactic structures. New chances to appreciate that consciousness itself might be the universe's greatest achievement, its most sophisticated method for experiencing and understanding its own nature. But for now, let yourself drift into the gentle currents of sleep, carried along by the natural flow of neural processes that connect you to every other pattern of organized complexity in the cosmos. Your dreams await in the curved spaces of imagination, where the universe continues its eternal exploration of what it means to be aware, to experience, to exist as both observer and observed in the grand mystery of being. The whispers of science that brought us together tonight will continue echoing through your rest. Subtle reminders that reality is far stranger and more beautiful than it appears on the surface. And when you wake, you'll return to this waking dream we call ordinary life, with perhaps a slightly different relationship to the weight of your body, the pull of the earth, the sensation of being held in place by what we now know is not a force at all, but the elegant geometry of existence itself. Sweet dreams, fellow traveler in the curved corridors of spacetime. May your rest be deep, your dreams be wondrous, and your awakening be filled with continued curiosity about the beautiful illusions and deeper realities that surround us always in this most mysterious and magnificent universe we call home.